Hello everyone, this is Amika Mahajan. Welcome to my channel. In this video, main focus will be on total internal reflection. Excellent sparkling of diamond, mirage, looming, all are examples of total internal reflection. Before understanding total internal reflection, let's understand what is internal reflection. When a ray of light is incident from denser to rarer medium at interface separating two media, what we find here that some part is refracted and some part is reflected back. So this partially reflected light is internal reflection. Now, to understand total internal reflection, look at this figure, try to understand this. When a ray of light is incident from denser to rarer medium at interface at an angle of incident θ1, then it is bending away from the normal, and θ2 is the angle of refraction. As we increase this angle of incidence, this angle of refraction also goes on increasing until a stage is reached when angle of refraction becomes 90 degree and refracted ray is along the interface. So at that time, this angle of incidence is critical angle. It is noted by either θc or c. These are two symbols for critical angle. Now, if I increase this angle of incidence further beyond this critical angle, then what happens? The ray, instead of undergoing refraction, comes back to the same medium. This phenomenon is total internal reflection. यानी कि कोई रे ऑफ लाइट अगर किसी एंगल ऑफ इंसिडेंस पे डेंसर से रेयर मीडियम की तरफ इंटरफेस पे इंसिडेंट होती है तो क्या होता है, बेंड अवे फ्रॉम द नॉर्मल. जैसे जैसे हम इस एंगल ऑफ इंसिडेंस को बढ़ाते जाते हैं, एंगल ऑफ रिफ्लेक्शन भी बढ़ता जाता है. एक ऐसी स्टेज आ जाती है जब ये एंगल ऑफ रिफ्लेक्शन 90 डिग्री हो जाता है, यानी कि रे किसके अलोंग रिफ्लेक्ट हो जाती है, इंटरफेस की सरफेस के अलोंग. उस वक्त जो एंगल ऑफ इंसिडेंस होता है उसको क्रिटिकल एंगल कहते हैं. लेकिन अगर एंगल ऑफ इंसिडेंस को उस क्रिटिकल एंगल से ज्यादा एंगल पे ले आए, यानी कि इंसिडेंट रे क्रिटिकल एंगल से ज्यादा एंगल पे फॉल करे इंटरफेस फ्रॉम डेंसर टू रेयर मीडियम, देन व्हाट हैपेंस, इट कम्स बैक टू द सेम मीडियम. तो इसी को हम टोटल इंटरनल रिफ्लेक्शन बोलते हैं. अब ये क्रिटिकल एंगल क्या होता है? लुक एट दिस फिगर. हियर इज रे रिप्रेजेंटेड बाय रेड कलर. दिस इज रे, इंसिडेंट रे at an angle of incidence equal to critical angle, जिसको मैंने यहाँ थीटा सी लिया हुआ है, इसको सी भी ले सकते हैं. What I find, this θ2, this not θ2, this angle R becomes 90 degree. तो उस वक्त ये जो एंगल ऑफ इंसिडेंस इसको क्रिटिकल एंगल बोलते हैं. सो व्हाट इज क्रिटिकल एंगल? एंगल ऑफ इंसिडेंस एट व्हिच व्हेन अ रे व्हाइल ट्रैवलिंग फ्रॉम डेंसर टू रेयर मीडियम is incident at interface gets refracted along the surface is known as critical angle. अब हम इस critical angle की वैल्यू भी फाइंड आउट कर सकते हैं अगर हमें मीडियम का क्या पता हो, रिफ्रैक्टिव इंडेक्स. वो कैसे? We know that when I is C, then R is 90 degree. So when I put this value in Snell's law while traveling from denser to rarer medium, what I find, refractive index while traveling from denser to rarer medium is sin C by sin 90, but sin 90 degree is 1. So D and R is sin C. By principle of reversibility, we know that refractive index while traveling from denser to rarer medium is reciprocal of refractive index from rarer to denser medium. So when I put this value in this one equation, what I get, 1 by R and D is sin C. Taking reciprocal on both sides, what happens? This refractive index while traveling from rarer to denser is equal to 1 by sin C. So if rarer denser is air and denser medium is glass, rarer medium is air and denser medium is glass, then absolute refractive index of glass will be reciprocal of sine of critical angle. So this relation you have to memorize for your numericals. Now we will define total internal reflection. It is the phenomenon in which a ray of light while traveling from denser to rarer medium is incident at an angle of incident greater than critical angle, then it comes back to the same medium, and this phenomenon is known as total internal refraction. So for conditions for total internal reflection to take place will be a ray should travel from denser to rarer medium and angle of incidence should be greater than critical angle. And also in total internal reflection, there is no transmission of light. But in case of simple reflection in which ray of light falls on plane mirror, it goes back to the same medium. After striking that plane mirror, what we find that intensity of reflected ray is not same as that of incident ray, as some transmission of light also takes place. And simple reflection can occur at any angle of incidence, and ray may travel from denser medium falling on mirror or from rarer medium falling on mirror. There is no particular choice of medium in simple reflection, but in total internal reflection, the ray should always travel from denser to rarer medium, and it should fall at an angle of incidence greater than critical angle. जबकि simple reflection में किसी भी angle पे ray incident हो सकती है plane mirror. Thanks for watching this video. Like, share, subscribe my channel.